Thanks for joining. This is part 2 of our Running Reliable System meetup. Again, we have Leonid with us, and he will run this second session on service level objectives, math. And before he does that, I'd like to quickly go through a couple of slides. We'll go quickly because I think you heard this before. And I don't want to take too much of Leonid's time, because if I remember well, the previous session, we had quite a lot of questions at the end. So we don't have a Munch and Learn for now in January. I think it's probably too late now to do a good job at one in January. So we'll probably skip to February directly. You can follow what we have on our Munch and Learn page. We are going to copy the links, not in the chat because there's a problem with cut and paste, but in the Q&A. And my colleagues, Denis and Mathieu, will do that for us. And we have meetups coming up in the pipe for the beginning of the year. So meetups are more in-depth technological sessions on open source technology or HP technologies in some cases. For January, we have a session planned on infrastructure as code with HP GreenLake. And in February, we have a session planned on Galadriel, which is an extension to SPIF Aspire to handle federation. Both of these are handled and delivered by HP engineers. So feel free to register for those. The links are already up in our meetup page. And I think Denis will probably put the link in the Q&A. Again, we also have a couple of other things you might be interested in for learning new technology. We have, in particular, these workshops, which we call workshops on demand. We have 29 workshops in our catalog. We use Jupyter notebooks for delivering, and this is available 24/7, free of charge to anyone on the internet. We have more on this 29 workshop. We have 15 of these are kind of open source on Docker, on Kubernetes, on some languages like Rust and Python. So give it a try. And if you do, please provide feedback. This is very helpful for us to understand what you liked, what you didn't like, and what else you'd like to see in this catalog, basically. Finally, remember, this is a community work. So we need your help to continue to amplify and contribute to the community. So please join our talks, our upcoming talks. You can forward the invite to other people so they can join. Remember, these are external talks. So you can invite customers and partners, students at university, there's no problem. Your colleagues, of course. We have a monthly newsletter to keep track of what we deliver and what we have available as blogs or upcoming events. So you can sign up for this. That's kind of the easiest way to keep track of the activities and things that we might deliver that are of interest for you. We have a dedicated Slack workspace with different channels for asking questions on different technologies and open source projects. We have a Twitter handle with a huge amount of followers. You can add yourself to that. Engaging in a more concrete way is, for example, writing a blog. There is a very easy way to contribute to our blog site. We use GitHub and Markdown, more or less, to write blogs. So you can easily submit a blog. This will create a pull request for us. We'll go into editorial and technical review with you. And then after a few days, the blog can be up on our website. If you're a subject matter on something, please share your knowledge with these blogs or deliver a meetup. That's also an option. We're always on the lookout for good sessions and good speakers. And finally, we can also build a workshop on demand if there is interest from your side, and if you can help us with that, of course, because we are quite a small team, can't do everything. And that's it for the community part of it. We have a QR code here with all the links that were also copied in the Q&A. Developer.hp.com is the website. And with that, I'd like to invite Leonid for the real content of this second session. Thank you very much.
Hello, everyone. Thank you for joining. Today, we will continue speaking about site reliability engineering. Specifically, we will talk about some math behind calculation of SLOs and see how different design decisions may influence your front door SLO as well. Before we move forward, let me introduce myself. My name is Leonid. I'm a developer relations engineer at Google Cloud based in Seattle, United States. My domain of expertise is observability and reliability with focus on payloads running on JKE, which is a managed Kubernetes solution in Google Cloud. In my previous role as a strategic cloud engineer, I helped enterprise customers establishing their SRE organization and migrating workloads to cloud. In the previous meeting, I've left few questions unanswered, so let me try to go through these questions quickly before we start speaking about SLO. There were 5 questions. First was, what should the max pager count per day be for SRE for a well-managed production system? A range would help. So in SRE, pagers are usually meant to alert on-call SRE engineers about incidents that require immediate attention. Alerts about other problems should be less interruptive and either handled by robots and automations, or propagate to the ticketing system and handled as a part of the SRE team ongoing work. So the number of pager calls depends on your SRE team capacity to accommodate incidents and your production payload to generate new ones. Ideally, it should not exceed the number of available SRE team members on call. So if you want to learn more about on-call duty and incident management in SRE, I would recommend you to read through chapters 8 and 9 of the SRE book. Is the Elastic Stack often used to enable SRE? So we had a similar question about the tool set in the previous Q&A session. And as I mentioned, there is no established tool set for SRE. And obviously, it is a both good and bad thing. Many customers tried reusing their existing infrastructure and service stack for SRE as well to save costs. I can't argument in favor or against it, and each case should be inspected separately, of course. I did saw elk stack being used for both troubleshooting and improving alerting logic. And it probably can also be used for some kind of automations. My recommendation is to leave the decision about the tool set to the SRE team itself, so they will be comfortable with instrumentation. And additional consideration of reusing the existing tool set is that internal products should be reliable no less than commercial products, and reusing the same service for multiple goals generally decrease the service reliability, which can be another factor in the decision. You mentioned 70% of the outages are caused by change management. Are there any best practices you can share around change management? The good change management is about managing risks. As we said, some incidents will always happen no matter what we do. So failing fast with established automated rollback processes allows you to mitigate the source of outages that changes bring. I would also recommend to utilize error budgets to get earlier notification that will help you to manage the rate of changes, or even when you get to the end of your error budget, just to stop any changes until you restore reliability. Is there a minimum size of developer community or company to implement Google SRE? So the first principle of SRE states that the reliability is the main feature of the product. As such, having it doesn't depend on the size of the workforce that you have. As I mentioned, having designated SRE team is not requirement for implementing SRE, so you can implement SRE in your company organization without having dedicated SRE team or even people with the title site reliability engineer at all. A one-man startup can implement SRE practices as good as a big enterprise. Just one important thing to remember is that SRE requires buy-in from all groups, business, developers, and operations about the SRE principles and about the agreement of SLO and error budget management. And of course, the smaller the company is, the more chances are same people kind of wear this multiple hats. So you can have people that both developers and operations roles, which makes buy-in simpler. But again, if you don't see reliability as a main feature of your product, then there is no reason for you to implement SRE in the first place. The last question, how do you decide the uptime of what? The uptime is operating system, for example, doesn't properly measure available of customer business application. This question was asked in Slido Q&A, and I'm not sure I understand the second part of the question, honestly. So I will try to address the first part and to my best, the second part as well. So in SRE, when I spoke about uptime, I basically meant availability SLO in the terminology of SRE. And any SLO basically, as I described, is measured in the ratio of good events versus total events. Meaning it comes to the definition what events describing availability of the service in a particular critical user journey are good versus that describes the service as available. So to give a simple example, if we speak about some website, in the previous session, I spoke about website uptime. So what does it mean for the website to be available? So in general, you can think about any request, HTTP request that is sent to the site and get a response as an event. And good events will be probably any responses with the HTTP status from the group 200 or 400, because 400 errors are not error of the backend, they are more error on the client side. Thinking about it, it makes sense versus the conventional uptime, because if the site is down but no one calls it, from the user perspective, the site is as reliable as at any other time. So here is the tricky part where you will measure this request if the site is down, right? So basically, it is a large topic, but in general, we will be measuring it somewhere on the infrastructure layer, like load balancer or somewhere else. Okay, I hope I covered the questions from the last time. And now we will be talking about how to compute SLO for complex architectures with multiple dependencies. And we will also discuss how we account to the rest of the infrastructure stack, in our computations. In this talk, I assume you know what SLO is. Such things like what I mean when I say SLO is 90% make sense to you, and notations of 2 nines, 3 nines, 3½ nines is familiar as well. We will do some probability calculations on the way, but you shouldn't worry. We will include a very quick 2-3 minutes crash course into the math of the probability. Okay, let's begin. I've worked with many teams and groups in enterprise companies that were on their way to establish a reorganization. And a question is always asked, how do we define the SLO? Teams usually struggle, especially if we are speaking about new service, but also the well-established service that people are looking to introduce reliability measurement into it. What exactly value should be selected? How to avoid choosing the wrong value? What if other teams that depend on our service will not be satisfied or come with high requirements? What are other possible outcomes of choosing SLO? So the guideline is very simple. You should remember the second principle of the SRE, stating that users are those who define the service reliability. So SLO should reflect how users perceive the service. Are they unhappy from the service, or they are not? SLO measurement is based on different indicators, so the user happiness should be measured using the same terms. Is the service available enough? Is it responsive enough for the users? Does it display the data that is fresh enough for the users? And so on. And you will want your SLO to reflect these users' expectations. Your users deserve the level of the service they expect, but this level should not be perfect or as great and maximized as only possible. It should be just good enough to keep your users happy. Remember that the higher levels of reliability it comes at a high cost, and this cost grows exponentially with each additional 9 that you add to your SLO. Also, adding each 9 seriously decrease feature velocity because it decreases total error budget, removing your chances to do different new things in the service. So you want to maintain the level of SLO that is good enough for your users and not beyond. Also keep in mind that SLOs are used in SRE not only to monitor the reliability of the service, but also to establish the communication between business developers and operations. So they can talk with each other using the same language. So the front door SLOs are often calculated based on the metric of the service, but as they solely depend on performance of the service itself, you may argue that such thing as a standalone SLO does not exist, and you will be right. There are many other elements in the picture. The service doesn't run alone. So the truth is that you almost never own the entire stack. It is not just other components that other team own and your service use or calls. There are third-party service providers, internet providers, network links, power grids, cooling solutions, you name it. Even if you deploy into cloud, you don't get rid of all these dependencies. So how do we deal with this? Let's begin with some maybe naive approximation. Let's try to compute a SLO for a service that has multiple layers of dependencies. So what if we just pump more reliability in each underlying level? Let's, for example, add another 9 to a SLO for each level of dependency and see should it guarantee that upper level will get the desired SLO? So let's start with 2 nines expectation at from the users. So our service SLO, based on what we said, should be 99%. So let's assume our service is a web service, so it runs on top of the web server software. This software then should give us 3.9 SLO. If we depend on other components like database, it will have to have a 3 or maybe even 4 nines SLO as well. Now, our web server runs on hypervisor, right? Today, we almost don't run on the bare metal. So the hypervisor will have to have 4 nines. The hypervisor is running on some infrastructure. The infrastructure will have to give us 5 nines, and we can continue forward. So is it realistic to reach this level of SLO in nested levels, like 5 nines, 6 nines, and so on? How much will it cost? And do we actually need to pump one more 9 in each underlying level? So we will uncover these questions in a few moments. But to continue, let's inspect 2 strategies for organizing the stacks that IT and operation apply in practice. We can depict them as pyramids. The first one is kind of legacy strategy, can be presented as a conventional pyramid with the wide stable basis. It is focused on each component's reliability. The second one is more modern strategy. It can be seen as a flip pyramid, where the basis is less reliable and less demanding for its components, but providing the desired reliability level at scale. So let's look on them closer. The legacy strategy tries to reach the total availability of all components in the stack by maximizing availability of each component. So make a very large cold room, fill it with a very performant, reliable, and as a result, expensive computers. Fill it with lots of redundant power and network supplies. Never let it go too warm. Use only extremely tested software and very expensive equipment. Close and lock the door and never touch it again. As the name of the strategy implies, everything is up as much as possible. And this worked for airlines, for example. And what can go wrong, right? Apparently, what this setup missing is scalability and flexibility. So, for example, due to security requirements, you might need to upgrade your firmware, install new drivers, install next version of operating system or third-party components, because you can't run your system with known security vulnerabilities, right? You might need to add new features to the application. Adding new features may require to replace or add more hardware. Adding new hardware is a strain on communication and power and cooling solutions. And as you know, any change introduces reliability risk. So, and you have to test every change you make. So it becomes super expensive and take like forever, because you have to own everything, and because the price of any change is very high. And still, at some point, you don't own things like power grid you don't own. So there is still a chance for unreliable behavior exists. You can't eliminate it fully. The second strategy comes after development of clouds and something better fitting a warehouse scale. So the idea behind it is that if you can achieve a consistent level of imperfect reliability, you can get a lot more flexibility and scalability, which in turn gives you more security and overall more reliability. With it, you can use what we like to call SLO-based reliability at many layers. You also can think about it as a kind of probabilistic sorry, reliability or aggregated reliability. Remember that it is much easier to get 2 or 2.5 nines reliability for a single component than 4 or 5 nines, not speaking that it is much less expensive. Besides scalability and flexibility requirements and security threats, the system architectures themselves become more complicated. We've seen the rise of multi-tier applications, service-oriented architectures, then microservices came. Today, service meshes are the most popular approach. In our SLO computation, we want to make sure we are taking advantage of their virtues and not just shuffle the new things onto the old model. So it is a time to blow dust off from your math skills. But don't worry, we are not going to test them at the end. So let's do a quick skill refresh about math behind probability. To demonstrate it, I will use dice as an example. I will start with the standard 6-sided dice with sides numbered from 1 to 6. So a chance to roll a particular number is 1/6, or approximately 0.167, right? So let's nominate rolling 1 as an outage. Then probability to have an outage is a 1 out of 6, which is 0.17, little less than 1/7. And obviously probability of not having outage is 5 out of 6, which is approximately 0.83. This looks like an availability SLO for us, right? So because it is a ratio of good events versus total possible events, 5 out of 6. So what is the chance to avoid outage if we have 4 services? In this case, or it will be the same as rolling 4 dice, right? So it is same as not rolling 1 in all 4 dice, because we need all 4 services. As you can see, it is almost half of the SLO for the single service. What if we have more sides to our dice? For example, 10. Then to have SLO for 4 services, meaning the top service and all the others, will be 0.65. What if each dice has different number of sides? Like in the example on the slide, you can see it is even smaller. So the important thing here to pay attention is that the more dice we add to a throw, the worse SLO we get. We never get the better result than the first one, the SLO of the first one. So how do we compute our service SLO when we have a complex distributed system? And remember that with distributed system, one of its properties that something can go wrong outside of your reach. It can be computers that you are even not aware of. This is the nature of the distributed system. It also has different capabilities like horizontal or vertical scaling and partitioning and some corresponding replications and more. And at first glance, all of this makes much harder to even reason about the system. So let's start with something more simple first. So what if we have services that depend each on another in a straight line? For example, we have 3 services, each having 3/9 of SLO. And like in our example with the dice, we essentially multiply each SLO on another, and we get in total SLO in the power of the depth, which is 0.997. As you see, even if we have a reliable infrastructure in underlying levels, the choice of architecture when we create such a dependency may have a lot of consequences on our SLO. And as we saw with the dices, we can't get as good a SLO as a single service. But what about pumping additional 9 in the underlying level that we did before? So let's try to do it. The math says, as you see, it is still not good enough. It is close. We relatively close to 3 nines, but we still don't reach it even with the case of adding additional 9 to each underlying level. What about if we make our services parallel? Does this change the thing? Actually, no, not really, because the change in the way of accessing the service doesn't change the fact that we still need all 3. The math is essentially will be the same. This is a very common pattern. My service makes n requests to n services. They all need to answer in order to render a result. Think again about an example with throwing multiple dice. We are talking about rolling 3 dice and suffering an outage if at least one of them has 1. This setup has an improved latency SLO if a user calls these services equally. However, it doesn't help with availability SLO. This setup can be improved to availability SLO only if the dependencies are soft dependencies, meaning there are conditions that not all services down the stack has to answer, or when service A calls services B and C separately and can bear with one of them failing to respond. As an example, think about service A as some kind of front-end UI application, and service B a service that provides profile information being displayed, and service C provides, I don't know, history of orders. And then your user will not be unhappy not seeing all details of the profile information as long as they will see the history of their orders, because probably in this particular user journey, this is the main thing. What if we have independent copies of the same service? It means that as long as one of them is available, everything should be okay, right? So it presumes there is some kind of retrying mechanism in place at load balancer, or Caller does it, but it is not the matter now. So the probability of the outage is 1 minus service SLO. It gets smaller with more copies of the service we add. Given we have 3 dice and we have to roll 3 of them, and for us it is enough that only one of them is not 1. So in this case, a new computation formula is here, and in the specific example with 3 copies of the service, the failure ratio is only 8 zeros and then 1. It is totally neglectable. So applying this formula, we get 9 nines of availability SLO, which is amazing for only 3 replicas. Again, remind you, we use here greatly simplified model. But still, it is great, right? Getting such high SLO rate just by a simple redundancy. So these results bring us to what we call a set theory of SLOs. We can distinguish 2 models here. One is where we require all dependencies to be met, and we call it an intersectional availability. It is calculated by the formula of multiplying SLO of each service, or SLOs in the power of depth. And another one where we need at least one of the dependencies to be available, we can call it union availability, and it is calculated as a complementary of the multiplied failure ratio of each service. In the chart, you can see computed SLO for some inputs under each model, with the assumption that all services in the model has the same availability SLO. Looking at it doesn't leave place for question which we want to use, right? So what is the problem? Why aren't we swimming in nines? Where are those services with great endless availability? Turns out that things like network and load balancing are a bottleneck. We don't own them most of the time, and they can be big and hard to fix. Also, there are a lot of reasons why systems might go down that we cause ourselves. Changes, mistakes, taking shortcuts, not doing enough testing, not having prompt recovery processes and mechanisms. Finally, when we do have outages, we don't often learn from them very well or deeply enough. There is often a tendency to aim to the quickest solution or the most shallow answer. The details of an outage are what really matters and what we need to be fixed. Some of these problems can be mitigated. We can learn from outages by doing a thorough postmortem and studying all outage details. We can improve reliability at each element of the software development lifecycle. We can automate toil to eliminate human factor where it is possible, and by this to reduce risk even more. For the rest, don't worry too much about downward implications of your SLO choices. Make sure you focus on your customers' happiness. Set the right goals at the front door SLO, and set customers' appropriate goals and work with your stack to meet them. Use outages to understand the details of the resilient engineering needed. Make sure to help infrastructure teams into the new world of cloud and distributed services if they aren't already. The resilient software can make infra's life easier. Remember that while you might own the whole problem, it is still a team's effort. So here are two models that you can use. The first is stacks. It uses traditional stacks of software and infra. Second is full mesh. As the name implies, it heavily utilizes redundancy and parallelism in all its components. However, it is a lot harder to accomplish, but gives you lots of functionality and ways to do things like draining and spilling. So in first model, you essentially can create multiple copies of your stack and deploy it in multiple geographic locations. You can take advantage of load balancing to make geographic dependent routing with retrials. And you can leverage the combination of intersection and union availability to compute the SLO of your service. The second model has much more flexibility built in into the architecture. It scales much better and allows reaching higher availability. However, it comes with a very expensive operational costs. As you can guess, it is very demanding for design and security of its elements, and also has a very high cognitive cost for understanding and maintaining it along the time. There are other models, of course, that I didn't touch. One of the called Megalith is an attempt to improve legacy monolith architecture, which just deploys copies of some monolith components around the world. But its main drawback is still the same. If anything fails anywhere, as a whole thing fails. There are also all kind of YOLO models that basically mean that you figure out yourself just how you go. And again, for this kind of approach, I can only recommend that you at least keep the stacks and full mesh models in mind when you design one. As we saw, to maximize availability, the full mesh model is the best, but it costs a lot in terms of resources such as compute, storage, and networking, and operational efficiency. Other capabilities that your product might require, such as immediate consistency or sharding or replications, become really complicated to implement in this model as well. You are welcome to do additional reading to help mitigate some of the problems here. Things such as failure domains, graceful degradation, regional versus zonal replication can help you in your path. We don't have capacity to cover all these topics in this talk, of course, but you can investigate them further. As we saw, the scalable reliability strategy, when the SLO of the components at the bottom of the pyramid is loser, allows us to build the better reliability towards the top via parallelism and replication. Because this resilience we are engineering, you can build more reliable things on top of less reliable things. The model for it is a full mesh, and I demonstrated the math that provides how it works. The reason why this method doesn't create an ultimative reliability of 10 and more nines is because simply we still don't control the whole stack, no matter what. The end-to-end experience very rarely will come anywhere near even 6 or 7 nines, not talking about 10 or more. However, it lets you use this model to achieve 4 or 5 nines reliability despite physical restrictions. Again, this is the big takeaway to go home with. You can build more reliable things on top of less reliable things. As a simplest example of this approach from the real life, think about RAID, like RAID 5 or 6, for example. If you haven't seen it yet, watch Yaniv Aknin's talk. Yaniv is a site reliability engineer at Google, about how you build reliable things on top of less reliable. The link to this talk is at the bottom of the slide. Slides will be published in the HPE meetup site later. Another takeaway from this is that you don't want to break up a system based upon where the manager is or which team owns which part. Your SLO should always be built for the systems at front door, not the component. Try to think about the system boundaries in terms of scalability or where the data is replicated, things like that. Try not to get frustrated by potential bad math that prevents you from making good choices. Build the systems that focus on customer happiness. All else will follow. Thank you.
All right, thank you, Leonid. We have a couple of questions in the Q&A. If you can take a look, we answered some for the book and for the slides and everything, but we left the difficult one for you.
Okay, so suppose some, just give me a sec. Okay, suppose some of users lose access to the site and some not. How do you account for downtime in this scenario? Would you multiply the downtime by the portion of users that lost access, or do you still count the whole downtime even so some users are still see the service as available? So let me start actually from clarification. What does it mean users lose access to the site? So when we define an SLO, we always not define it just generally for the service. We define it for a specific user journey that is critical. So for example, I can interpret users losing access to the site as something that user types in a URL in the browser and they get an error. If this is kind of the problem that you see, it is actually a problem that you have to take into account. And the implementation will be to establishing black boxes, which will run once in a while an attempt to access your site from different geographic location. And they will report this experience because, again, a number of hops on the way from a user to even your load balancers that dispatch the requests that we usually recommend to measure availability SLO, can be very long, like there can be at least 2 internet providers on the way, there can be some underwater cable on the way, and so on and so forth. So it is possible that you won't be able to catch up this incident where you usually measure your SLO. So for this matter, you will have to establish additional means to measure your SLO. And then to mitigate it, so again, you will get this reported, you will see your SLO going down, your error budget is exhausted, and you will have to address it. And addressing it will probably mean that you need to introduce multiple copies of your website in multiple regional locations to mitigate this long path to your backend. And provide the better availability. Or, for example, you can get a response that even losing 30% of all users doesn't create a buzz. So if it doesn't create a buzz, meaning the users are still happy. And happiness of the user, by the way, it is like a topic that we can speak about another hour. How you measure it, actually, like. You put some chip inside the people, or what do you do? So, but for example, one of the ways is like post-factum measurement, when you follow Twitter and all forums, if people like express their annoyance because I tried and I couldn't do it. And you might discover that your most of your people like located in US, all your customers are in US, and like a small fraction located somewhere, I don't know, in far east or whatever. Or, don't want to pick location so no one will catch me on it. And their happiness doesn't mean too much from the business perspective. Again, we are speaking about user happiness, but let's be truthworthy. All this happiness matters in the respect to the business, right? So you might decide that actually you don't need so high SLO so high, and you can live with this. But if you discover that you need it higher because you can't capture it, you will provide it by meaning of replication, geographic replication, and other things. But to capture it, and you will need to get kind of accounted to this, and to capture it, you will use some artificial clients positioned in geographic location. Amazon, for example, or any other cloud provider gives you this option by just selecting a region and establishing a client there that runs and then reports the measure. The second question from Mohammed, another question is related: the service is available, but it is very slow, not down to practical do anything by the user. Would this count toward downtime? So again, availability and latency are different metrics to measure. So it all comes to the definition what events capture this specific property and which of them are defined as good versus the rest. So if for you availability still conditioned by the time, I personally would investigate it further, because by basic definition, these two things are different, and to mix them will introduce a certain strain on the way how you measure it. So I would recommend to separate them. But you can always define a combined SLO. There are methods and processes to create a combined SLO, which uses two separate SLOs, one for availability, one for latency. and combine them together. However, I suggest you to consider that actually not a good thing to mix them together is a simple reason how you mitigate. If your service is not available, you probably will be able to create some simple automation by maybe restarting all instances. And it should usually do the work, especially if you do postmortem and you analyze, for example, that availability was affected by, I don't know, capacity problem. And for latency, it is totally different approach. On much more chances are that restarting service will not help you with latency. So generally, I would suggest not to mix these two, and to say that if the service is slow, you should have latency SLO properly adjusted, and then you have to treat this incident as incident with the latency. Any other questions?
There's another question in the chat from Vinaya.
How to come up with error budgets for new services? Is it reasonable to allow some service to have higher error budgets? So error budgets are essentially is a complementary thing to the actual SLO. So essentially, 1 minus SLO is your error budget. Again, it is a slightly simplified model, because once we start speaking about actual measurement and how it is measured along the time window, things become less obvious than when we just speak 1 minus SLO. Okay, but essentially, defining error budgets for new services, it is the same as defining SLO for new service. Once you define your SLO, like 99% of the time, your SLI should be above 99.5%, and the time you measure is like 1 day, for example. Then during this day, this is what happens. And if you start experiencing incidents, it starts cutting off from your error budget, and your SLO decrease along this window. And then you react. Okay, so the challenge of defining a new SLO for a new service is a challenge to guess how much it should be in order to keep your users from being unhappy. And from this, clearly, it is possible that some services can have higher budgets, aka lower SLO, than others. But it is not like goals. We have 5 services, all of them have 1 error budget, and then we like distribute error budget among them. For each of them, you will have to calculate the front door SLO. This front door SLO has to have a meaning of keeping users, consumers of the service from being unhappy in the particular, again, user journey, and particular SLO like availability, data freshness, completeness, latency, whatever. And this SLO should be accountable to all things along the stack of dependencies. And then you get your error budget. How for new how to select new SLO for a new service? In 2 words, you will have two methods. One, you guess, and then iteratively you start improving it. Second, you look on the previous data that you might have from a similar service if you replace the service, or you have some previous data from other services around that you want kind of you can compare. And then you define your original SLO based on this data. And then again, you define iteration cycle, like months, 2 months. That after that, you come and see how many you analyze users' feedback, you analyze the rate, and you see if this SLO was selected right or you need to adjust. Any other questions?
Thank you, Leonid.
What is that SRE book name again? Can you please put it in the chat?
I think we answered that question in the Q&A.
You answered it?
You can take a look if it's the right book, but I think it is. If you look at question number 3, I think it is 1, 2, 3, from Tushar Otia. We answered with a few links, and I think probably links.
Okay, everyone.
Also, for the rest of the people still here, we'd like you to fill up the 3 questions in the end of session survey. That would be great. Thank you very much.
Okay, I've put a link to the online copy of this book that I mentioned into the everyone's chat. So I hope it will help.
The Q&A there.
So you don't need to buy it. This particular book is available online.
Thank you very much, everyone.
Happy holiday. Bye-bye.